In this exercise, we'll be going over 12.6 writeSquares. So this is another interesting recursion problem. So it's going to print out all the squares, but it's going to print out the odds first, and then go to the evens. So let's map this out. So for when n equals 5, n equals 5, this is going to go, well, we want to go down, so we're going to go 5, 4, 3, 2, 1. And we see here, we're going to print this one out first, so 5 squared. And then we're going to print this one out second. And then our 1 squared. Or actually, no, I'm just going to put 1. And then we print out 2 squared. And then our 4 squared. So this is a bit more challenging. It's a bit more different than what we've seen before. But it's still very doable. So as we know, if we want to do recursion, we just always going to call n minus 1. But we have to do something that makes it so that when n minus 1 isn't even, we don't print it first. So, see this. We're going to have this out a bit more. So we're going to, well, we first have to check if, well, n equals 1. Then that's our base case, so we're going to return 1. Just print 1. Right? Now we have to check if it's even or odd. So if so this all has to be connected. This if statement all has to be connected. So there's an if here, and else if, and if it's even, mark. Then we have to print it last. We have to save it to the end. So that means we print n squared. When you print n squared, we have to print it before, we have to print it after we recurse. So that means we have to print the recursion, right? Seek writeSquares before we print, if it's even. We're going to do n minus 1, of course. And else, if it's odd, then we want to print it first. So we're going to print it out before we recurse. And then WS n minus 1. So that's how we get around that ordering problem. So we just change where the recursion happens. And that really shows how important it is where the recursion happens, because just by changing that, you can change the entire order. So let's put this into our code. Let's put our base case in. If n equals 1, then we get system out print 1. Alright. Else if n mod 2 0, so this is checking if it's even. And since it's even, we have to print it last, so we have to print after we recurse. And then, right, so we have to put in our spaces and commas. And then we want to recur, and then recurse 4. So writeSquares n minus 1. So it's going to recurse first, and then print it out. And then when it recurses, if it hits an odd number, it's going to print it out right out. N times 2, oh sorry, n times n, plus comma space, and then we recurse. Oh, hold on, sorry. So that should be it. So if we trace our code right here, let's just trace our code here. When n equals 5, it's going to go right to the else. Right here. So it's going to print out 25, and then go into n equals 4. So number 4, n equals 4 is going to go straight to n3. So this is our n3, and then n3 is going to print out 9. So then you're going to go straight to 2, which recurses first, and then prints. So it's going to recurse to 1. 1 prints out 1. So that means now all the recursion is done. So now all that backlogged prints from these two evens are now finally able to print. So now all the recursion is done. It goes back this way, goes this way, this way. So it's going to print out 4, and then it's going to print out 16. Right, and that's tracing our code. And this should, else without if. Oh, whoops, I forgot to put that there. I'm gonna just format this real quick. Alright, now it should work. Whoops. Okay, that's a spelling error. Alright. There you go. And that's how we do it. That's how we order things by changing where the recursion happens. And that is exercise 12.6. Thank you for listening.